Hello, I'm Bhaskara and welcome to my presentation of multiplexing and demultiplexing in the transport layer. Now, what exactly is multiplexing and demultiplexing? So, multiplexing is taking multiple signals or multiple things into one and transmitting it as one. And demultiplexing is the complete opposite of that, which is splitting one into multiple different parts. So in this presentation, we'll discuss about multiplexing and demultiplexing techniques, their importance in the transport layer, and finally we'll discuss some advantages and disadvantages about the same. Now, this figure shows the basic diagram of multiplexing, which includes multiple different inputs, one output, and demultiplexer takes the one input and gives multiple outputs. Now, what is the transport layer? The transport layer is a part of the OSI model and it provides crucial services. Now, what crucial services does it provide? It provides end to end communication. What is end to end communication? It does that it allows users to contact between each other. Additionally, with that, it is something which guarantees integrity and it has features such as error detection, flow control, and congestion control. Now, as we can see, the transport layer is the fourth layer after the application presentation, the session layer. Now, one of the most crucial responsibility of this layer is multiplexing and demultiplexing. In the transport layer, the multiplexing and demultiplexing of signals is involved. Now, there are two popular examples of transport layer protocol, which is TCP and UDP. TCP is Transmission Control Protocol and UDP is User Datagram Protocol. Now, TCP provides a reliable connection, which is reliability oriented, and UDP is a connectionless and it provides unreliable but very fast, low latency communication. Now, what exactly is a multiplexer? So, multiplexing is the process of collecting data from multiple applications or multiple sources and then making it enveloping it with data and headers and sending them as a whole to the intended receiver, and then at the intended receiver they can just demultiplex it. Now, as we see in this diagram, there are number of input lines and we have a multiplexer. We can select all of those inputs and get one output link. Now, using that one output link, it has headers and the data which can be carried forward. That one single data has all of the data. That is the main gist of a multiplexer. Now, the main reason why we do multiplexing is to increase the capacity of transmission medium. Now, if we use many different signals by themselves, then we have to transmit a lot of different signals. So instead of that, if we multiplex it, then it's pretty easy to transmit a single signal which includes all of the different inputs that we need to transmit. Furthermore, we can use multiplexing in various communication systems, which is telephone networks, cable TV, and satellite communication. So, in multiplexing at the transport layer, the data is collected from the various different applications. Applications, they can be Google or Outlook or Skype or any other communication application, Google, Hangouts, etc. Anything. Now, these segments contain the source port number and the destination port number, which is required from and to, and they have header files and data. Now, these segments are passed to the network layer. So there are different types of multiplexing, analog and digital. In analog, there is frequency division multiplexing and wavelength division multiplexing. In digital, there is TDM, which is time division. It's very simple. Now, time division multiplexing, what it does is it basically takes the input A, B, C, D and splits them into different time frames and sends them over. So it becomes a single signal. Now, for frequency division multiplexing, it is similar to time division, but the only difference is that there are different frequency bands that are involved and it is transmitted as different frequencies. It is a single signal which includes all of those frequencies. Now, wavelength division, again, it is similar to frequency division, and it is split into different wavelengths. As simple as that. Now, these techniques improve the effectiveness and scalability of communication by enabling the transmission of numerous signals over a single channel. So, what are the advantages? It allows for multiple data streams. Now, because we are running multiple data streams, we don't need to do it parallelly. That is why we are reducing the cost, and we are effectively reducing the time as well. And we have a very large bandwidth. But the disadvantages, it requires special equipments. It can limit the flexibility. It obviously increases the latency because we are demultiplexing. And if multiplexing fails, then the whole channel will be affected. Now, what exactly is a demultiplexer? It is the opposite of a multiplexer. So, a demultiplexer basically receives signal, it splits up the received signal and sends it to correct applications. As you can see, there is multiple input lines and a single output line. Now, it allows for efficient transmission of data over a shared medium by separating and directing them to intended destinations. Okay, so there are different types of multiplexers: one input, 16 output, one input, 8 outputs, and so on. So, so this is a basic example of demultiplexing and demultiplexing, which is used in the transport layer. So Google Outlook and Chatroom are the different applications which send their data along with their source number, port number, headers, and data, and then it is all combined into a single segment of data, that is multiplexing. And demultiplexing happens at the receiving end, and those data and port numbers are used to direct this data to the particular destinations. Exactly. So there are multiple different processes. We use a multiplexer to combine it into a single process, and then we send it to the destined IP, and then it is demultiplexed and sent to the different processes. The main objective of multiplexing and demultiplexing is to be able to use multiple applications at the same time without having an error in on any of those applications. And here we can see that application layer has generated the data. It is then passed down, and in the transport layer on the left hand side we can see that it is being multiplexed, where three input lines are being combined into a single input line, and it is being sent to the destination. Here in the transport layer of the destination side, it splits up the data into three parts and sends it to the different applications. After segmenting the data, port numbers are given to each segment to be ready for transmission. Then the segments are put on a wire to travel across the destination. This is called multiplexing. When they reach the source, they are split up, and this is called demultiplexing. In this presentation, we have discussed about multiplexing and demultiplexing. We have presented the basic idea behind these techniques, and we have listed some important advantages and disadvantages of both the techniques. Thank you. Thank you for listening.